One more solve the system. Let's graph this one. Y equals 3x plus 2. 0, comma 2 is a good point. And we have a slope of 3, so we'll go up 1, 2, 3 over 1. And that gives us our first line. We have 4/3 x plus 1. So we'll start at 0, 1. And then we'll go up 1, 2, 3, 4 over 1, 2, 3. That gives us our second line. Now, that point right there, what is that? Looks like it might be negative 2/3, comma 1/4. That's kind of hard to tell. Obviously, graphing doesn't work well for all systems of equations. Sometimes graphing doesn't give us the easiest solutions to read. So we've got two additional methods of solving systems, and that's what we'll be finishing up this module. First one is solving systems by substitution, and the other one is solving systems by elimination. We'll start off with the substitution method. In order to solve for that, we're going to pick one of the equations and solve for one of the variables. So just go with whatever's easiest. If you've already got a variable solved, use that. The next, we'll substitute the expression that we found in the first equation into the other equation. And that'll leave us with one equation that's only got one variable in it. We'll solve this new equation for that one variable, and then we'll substitute whatever we found into one of the equations to find the other variable. Alright, that's a lot of talk. Let's see how it works. Solve using substitution. First off, we want to get one of the variables alone, and we've already got that. This y is all by himself, so we've already got one variable by itself. 4x minus 2 is equal to y. So what I can do is take this 4x minus 2 and substitute it, that's why this is substitution, substitute it in for that y, and we get 4x minus 2 equals 3x plus 1. One equation is solved for y. I substituted that value of y into the other equation. Gives me one equation with just x's in it. And now I can solve that using techniques that we've used before. Subtract 3x from both sides, giving me x minus 2 equals 1. Add 2 to both sides, giving me x equals 3. Now I'm excited because I got to the end of solving that equation. I've got x equals 3. I really want to just circle my answer and be done with it, but that isn't the solution to this to this system. I now need to take this 3 and plug it into one of these equations, whichever one looks easier. Y equals 4 times 3 minus 2. I'll substitute it in and then solve for y. So 4 times 3 is 12, y equals 10. So my solution set, or my solution to the system, is a coordinate pair 3, 10. Now, that was a lot of work. It would be nice to be able to double check myself, and part of what being a solution set is that it has to satisfy both of these equations. Since I used the top equation to find y, I can use the bottom equation to double check myself. 10 equals, I hope, 3 times 3 plus 1, and yes, in fact, 10 is 9 plus 1. So this is my solution, and I have confirmed it's correct. Alright, 6x plus 3y equals 3, x minus 3y equals 4. If you have a variable that's got a coefficient of 1, in other words the variable is all by itself, that's often an easy quick solve to get that variable by itself. So I can add 3y to both sides on this second equation, and all of a sudden I've got the second equation solved for x. Alright, now the substitution, since x equals 4 plus 3y, I can now take my first equation, 6x plus 3y equals 3, and I will substitute this expression in where the x is. So 6 times 4 plus 3y plus 3y equals 3. I now have one equation with just y's in it, so I can quickly solve this for y. Distribute our 6. We get 24 plus 18y plus 3y equals 3. 24 plus 21y equals 3. We'll subtract the 24's. 21y equals negative 21, or y equals negative 1. Again, this is half of our solution. Our solution is going to be an ordered pair. It's going to have an x and a y, and we found the y part. We'll plug that back into either one of these. How about the x minus 3y equals 4. Plug it into here. So x plus 3 equals 4. X equals 1. Now once again, since this is a new technique, I want to double check myself. And I can use the other equation. Since I used the second equation to figure out what x was, we'll use the first equation to double check ourselves. 6 times 1 plus 3 times negative 1 equals 3. Yes, 6 minus 3 is 3. So I've confirmed that this 1 comma negative 1 is the solution to this set of equations. The other method we want to look at is the elimination method. Sometimes it's called the addition method. In order to solve using the elimination method, we're going to write both equations in standard form. That is, ax plus by equals c. If necessary, we'll multiply one or both of the equations by some constant so that the coefficients of x, or the coefficients of y, are opposites of each other in the two equations. Then we'll add the two equations to each other. Add the left side down, add the right side down, and because we have coefficients that are opposites, one of those variables is going to go away, and all we're left with will be one variable. We'll solve the equation for that variable, and then, like the substitution method, we'll solve for the other variable. Solve using elimination. Now we are already in standard form. 4x plus y equals 13, 2x minus y equals 5. So we're set there. We have a positive 1y and a negative 1y. So we are already set up to where the y's have opposite coefficients. We have plus 1, minus 1. If I add these two equations to each other, 4x plus 2x is 6x, y minus y, the y's go away. and 13 plus 5 is 18. I now have one equation in just x. Divide both sides by 6. We get x equals 3. From here it's the same process as before. Put the 3 in for our x. 4 times 3 plus y equals 13. 12 plus y equals 13. So y must be 1. So our solution is not x. Our solution is 3, 1, which can be confirmed with the other equation. 2 times 3 minus 1 is in fact 5. That's solving using elimination. Elimination can be very quick and very easy. It can also be troublesome.